Okay, in this video we want to demonstrate the 3D nature of our relational tables using primary keys. Now here I've got a database with a couple definitions but no tables. If I come out and I grab a 1 million row CSV file, drop it on our customer's definition and import it in, it's going to read in and create table with 1 million rows in it and put all the data in there. This data that is put in is just random names, addresses, cities, states, countries, etc. So once this table is created here, it takes a few seconds. If I do a select all on it, you'll see all the data, and we'll have lots of duplicates. So for example, for the city, there's 1,046 different cities, and there are 1,996 rows with Richmond in it. If I click on a city, you'll see here's the 932 cities that have Portland in it, for example. This is a standard two-dimensional table because we haven't created a third dimension. But because our tables are essentially key value stores, we can easily have a third dimension. So row number 1, for example, could have 8 names in it, Willow being one of them, and so that name value could be 8 levels deep. Now to demonstrate this, we'll come up to our customer definition here, and let's take email, for example, and make that a primary key. So we double click on that, put a primary key constraint on the email column. Oh, we also want to, let's add a new column at the end. Let's call this a counter column. I'll make that a type number. Now if we take that same CSV file and drop it on this customers table, just like before, but now it says there's a primary key associated with this definition. So it's going to ask us, what do we want to do when we have a collision on the email column? We just want to reject any new lines. We want to add no fields. We want to increment that counter column we just created, or do we want to create new levels? Let's start first with just incrementing the counter column. So we do that. We'll import it just like before. This time it will still get a two-dimensional table, but in that 11th column we'll have a count of how many collisions each particular row had as it imported all this data. The emails are fairly unique, but because they're random with 1 million rows, we got several duplicates. So this will count them up. That's finished. So there were only 677,000 unique values in the email column. So if we double click on there, you'll see for the email we should only see unique values. Yes, so everyone has just a reference count of 1. And if we go over to our counter column, we'll see how many duplicates there were for each row. So this Herod Sodalis.gov there were 5 different instances of it in the table. If we come and show the values here, you'll see that the most was 9. There were 4 rows with 9 collisions, a bunch with 8, 7, and as we got more and more, we had 175,000 where there were two references. So let's do that same thing, only this time, instead of incrementing the counter column, we're going to create new levels. So we're going to create a third dimension. So every time we hit a collision, we're going to add the other values in. So this will import everything. And so if we have a collision and there's a new name, we'll see two names in the name column. We'll see 3 addresses in the address column, those kinds of things. So the most depth because we saw in the emails the most collisions we had were 9, So the maximum depth of this particular table should be 9. And this takes a little bit longer to parse it in because we're having to check for duplicates as we import the data and create new levels in our three-dimensional table. So when this finishes, we'll be able to query it and view that third dimension. 960,000, 88, there we are. So now if we double click on there, you'll see that all the values that have multiple, so this particular row had multiple values in the name column. If we just double click on it, we'll see that it had 2, Carla and Cassandra. When we come over here to the zip code, this one had 3 different zip codes in that value. So we see a third dimension here. This one has 3 addresses. But the email column is still all unique values because it's a primary key. There's 677,788 rows, and away we go. We can also filter. So even though there's multiple values here, we can still filter on the name. So for example, we want to find everybody that had Audra in it. I could just double click here and we will again see those multiples, but every one of these where there are multiples and we double click, we should see Audra as one of those levels. Sure enough, there it is. We can also filter out by how many levels. So for example, we want to show where the name column had at least 8 or more levels. So boom, we got 18 rows where there were either 8 or 9. This one has 8. You should have some with 9. That one has 8. Keep going down. That one has 8. I think like there was only a couple with 9. Maybe it's the last one. Oh, that's 8. One of these has 9 in them. We've still got quite a bit. You could up that to 9, and there were 3 of them. So this one has 9, that one has 9, and finally this one has 9. Now because there's multiple values here, we select those rows, we could still show as JSON, and it will show you the 9 values for each of the various fields. We don't yet have it so where we keep them all together, meaning we separate the level on the key so that we can create a single to map that address with this city, with this country, etc. We just show you all the values for now. We're working on the various levels to keep the values in order. So we're still working on it, but this gives you a demonstration of some of the capabilities this system has. Thank you very much.